Is it easy to release consciousness into outer space? This is a question that puzzles many people. Currently, the Earth is facing approximately 9.1 billion tons of waste, while the land area available for handling this enormous amount of garbage seems increasingly cramped. People are considering sending waste into space due to increasingly severe environmental threats. The question is this feasible or not? The universe is constantly expanding. Space debris consists of fragments or leftover objects from human space exploration activities, currently floating in space. Space debris is similar to artificial satellites, both orbiting the Earth in fixed trajectories, forming a belt of debris. According to forecasts from the Johnson Space Center, US, if countries stop launching additional satellites and rockets, the amount of space debris will remain stable from now until before 2055. However, this number will increase over the next 2 centuries. The amount of space debris will increase from the current 9,000 pieces to approximately 11,000 pieces, as fragments collide and break into smaller pieces. The U.S. space surveillance system is currently tracking debris with a diameter of 10 centimeters or larger, of which 17% are rocket boosters, 31% are defunct satellites, and 38% are fragments from orbital collisions. Additionally, 13% consists of debris from other types of space equipment, with a total weight reaching up to 5,500 tons. Additionally, there are thousands of other debris fragments, primarily from satellite explosions. Man-made objects in orbit often shatter due to extreme pressure. GAC is primarily sourced from Russia and the United States. Since 1991, scientists have recorded 3 collisions between space debris pieces larger than 10 centimeters in diameter. The most recent incident occurred in January 2005, when a defunct U.S. satellite, after 31 years in space, collided with parts of an aircraft's equipment. However, none of these 3 collisions generated smaller debris fragments. The deadly debris in space. Researchers predict that approximately 18 collisions will occur in the next 200 years. Although collisions are not frequent, the consequences can be devastating, especially for expensive satellites or manned spacecraft. The debris can travel at speeds of up to 22,000 miles per hour, fast enough to puncture spacecraft or satellites, causing power outages. In outer space, the greatest danger comes from metal debris, as it can travel at speeds of up to 1.6 kilometers per second. At such extremely high speeds, even a tiny metal particle as small as 0.5 millimeters can puncture an astronaut's protective suit. The 2003 Columbia shuttle explosion was assessed by NASA as possibly caused by the spacecraft colliding with an extremely small meteoroid or space debris. The region with the densest concentration of space debris lies within a range of 550 to 635 miles from Earth's surface. Since manned spacecraft cannot fly at this altitude, the level of danger is negligible. However, commercial or scientific satellites may still face this risk. Only by clearing large objects from orbit can we prevent potential dangers to the aerospace industry. However, currently, no feasible solution has been found for this issue, both economically and technically. To prevent space debris from colliding with spacecraft, researchers from the Russian National Aerospace System Institute conducted a study. The Institute of Applied Mechanics, after years of research and testing, has successfully developed a protective mesh shield to prevent collisions between aerospace equipment and space debris. This folding screen has a distinctive feature: it is coated with a special material. When a collision occurs, the energy generated from the impact causes the cosmic screen and sensory veil to produce a chemical reaction following the laws of color, transforming the fragments into a powdered form. This mesh-like screen also serves to guide space debris while creating a cross-sectional carved surface to increase contact area, thereby reducing impact force. One solution proposed by scientists to prevent the increasing problem of space debris is to equip satellites or rocket stages with a return trajectory to Earth after completing their missions. But this idea would increase costs, making the independent module and control system more complex. Another idea is to use ground-based lasers to deflect the orbital paths of space debris. But this is also an idea that's difficult to realize because the number of cosmic senses is too vast. and it would require an enormous amount of energy to operate the laser. Currently, there are approximately 9.1 billion tons of plastic waste on Earth, and this number could rise to 15.1 billion tons by 2050. Faced with numerous environmental threats, humans have considered sending waste into outer space. However, to send a symbolic object into space, the cost can reach up to $20,000 per kilogram of material. Each year, the United States generates an average of 250 million tons of waste. Transporting this amount of trash into space would cost hundreds of trillions of dollars annually. Even if the cost were to decrease, sending waste into space would still be unfeasible. The issue isn't just about money, but also many other factors such as orbital dynamics, materials, gravity, or radiation that need to be carefully considered. The worst-case scenario would be the waste-carrying vessel suffering an accident, causing radioactive material to leak out and spread to the seabed, severely harming the environment. Moreover, space pollution is unacceptable, as harmful substances released into space can disrupt the galaxy. In reality, Earth's orbit is turning into a space junkyard with over 500,000 pieces of debris. At a speed of 17,000 miles per hour, it could pose a threat to space stations and spacecraft. Therefore, sending waste into space is not feasible and could even harm Earth.